when you don't have a fraction, but you have a square root. Right? Do you remember, this is example 4. Do you remember this guy? Remember this guy? So we have some rules, again, for what values I can put in there, yeah? And what values I can't. Here, I want the denominator to be anything but 0. Anything but 0. What do I want about this? What do I want x to be?
Not 0.
Funnily enough, what's the square root of 0? Does 0 have a square root? It's the number that I multiply by itself to get 0. The answer is 0. So 0 actually, even though here it's not okay, over here it is okay. 0 is okay, 1's okay, 2's okay, 3's okay. What numbers aren't okay? What numbers can't I put in there? It's negatives, isn't it, right? As the second you go negative, like -1, -2, -3, you're in trouble. You can pop it into your calculator and it will very dutifully tell you math error, right? We can't deal with square roots of negative numbers, at least not for now. So all I need to say is, if negative numbers are the ones that break the function, that I can't put in, then what numbers can I put in? Just everything above 0 and including 0. So I would say this, right? Do you notice that? That's just very slightly different from saying positive values, because 0 is not positive. It's not negative either. It's a bit of a loner, okay? So there you go. That's what I've got there. And then I think the last example we did last time was this. I think it was a 5, okay? Now remembering that what I want underneath the square root, I want it to be greater than or equal to 0. Yes? So what I have under the square root is 5, take away x, greater than or equal to 0. And then we just have to solve this thing. How do I solve inequalities? They're a bit sneakier than equations. Someone want to give me a suggestion for what my first step might be? Okay, yeah, I've got a positive 5 here. Don't really want it there, so I'll subtract 5 from both sides. That leaves me with this. Okay. I've got a negative x there. I don't really want negative x, so what do? I can divide or multiply. Ends up doing the same thing in this case. Yeah, I'll multiply by -1. That'll make x over here and positive 5 here. But you have to be careful. The inequality, it switches around, right? Now, why does it switch around? Can anyone suggest, like, is that just random, arbitrary? Maths teacher just trying to add more rules to make things hard? Why does it do that?
Because when you divide, change the sign. Yeah.
Okay, we've changed the sign, but why does changing the sign change the direction? Like, if I say this, if I say minus x equals 4, right? I can multiply this equation by -1, just like I did here, and there's no problems. Like, I don't have to worry about any sign or direction or whatever. So why do I have to worry about it here with an inequality? Do you want to have a shot?
With an equal sign, both sides are the same, and with an equality.
Good. So this is half the answer. In an equality, right, you've literally got two things that are exactly the same. So you can do anything to the left and right hand side, and they're meant to be the same thing, so it should be fine. But here, the point of an inequality, like if I say things are not equal, okay, the point is that they're not the same. So you can't treat them as identical, which is what happens over here. Let's give it a quick example, right? I know 2 is less than 3, at least last I checked, right? You just calculate it if you want. But if I multiply both sides by -1, or any negative number, if I have -2 and -3 over here, is -2 still less than -3? And the answer is no. In fact, it's bigger, right? Because this is more negative. So you can see clearly, an example makes it really obvious why the inequality's got to switch around. And the whole point is, just as was mentioned, 2 and 3 aren't the same number. So -2 and -3 also aren't the same. Okay, so there's the domain. That's what we looked at last time. Now, how are we going to interpret range? We'll do it for this same set of questions. As you'll see, these are going to come out pretty quickly, right? Range means what are the y values we can get out? What can we get out of this, right? You put in as many x values as you want, and what kinds of outputs will you get, okay? Now, when you have a look at this graph here, 1 over x, just like horizontally, right, for the domain, when you look vertically up and down, there's still a single spot where you can't get y values. No matter what x value you put in, you'll never get a y value. What's the spot?
Y equals 0.
It's y equals 0. Can you see it now? I'll put it in another color. And if you have another color as well, maybe you want to indicate it on the same graph so that you can see everything I'm about to put in is going to be talking about range. Okay? Now, y equals 0 is off limits on that graph. It's off limits on that graph. So it's outside the domain. Sorry, outside the range. Right? It's not part of it. How would I state the range of this?
Y is greater than 0.
I can be, I'll try and do it in like small to big. That's usually the way we do things, just like went from small to big. So I can be below y equals 0, that's y is less than 0. Or I can be above, right? Which is what Eric just mentioned, y is greater than 0. Below, above, just not on the line, okay? Now, with this guy, interestingly, I've moved to the left a little bit. You see, I'm negative a half instead of 0. But I've moved left and right, nothing has changed up or down. Nothing has changed up or down. So you can see, I can make this number as small as I like. I can still get really, really tiny numbers, but I still can't get to y equals 0. There's no number you can put into x. Think about this, right? You could put 1,000,000 into this. You'll get a really small number, 1 over 2,000,001. That's small, but it's not 0. You can put in 1,000,000,000 into that. You'll get 1 over 2,000,001, which is smaller still, but it's still not 0. You'll never, ever get there, right? So you still have the same asymptote, you have the same range. Okay? So I'm going to go y is less than 0, or y is greater than 0. Okay? In exactly the same way, what does this guy look like? What does he look like? This graph, if you go ahead and you plot some points, you'll see it looks like this. I put a little filled circle on the end there to indicate I can put in x equals 0. It actually works. Just like the range, sorry, the domain is x is greater than 0 horizontally. What's the range? Where can I go? I can go anywhere from y equals 0 and upwards. You see that? So the range in this case is y is greater than or equal to 0. Okay? I'm going to leave off this one because it's identical.